In 3.4 graph in the microbreeze, I think I'm saying that right, we need to kind of take our two equations that we created in 3.3, and we're going to graph them. So over here on A, they want you to graph Tn. That was the bacteria problem. So N was equal to 500 times T to the, or 2 to the T power. So that's that equation. And then B was asking us to graph the parasite. So the number of parasites was equal to 100 times 3 to the T power. And it makes this little phrase, if you get stuck, go ahead and create a table. I always like to create a table or kind of have a table in front of me. So an hour T and number of parasites. So at the beginning, 0, we had 500 parasites. So let's plot that. At hour 0, yeah, I didn't spell that right, H-O-U-R. H-O-U-R. We had 500. So this is 1,000, 8, 7, 6, 5. What are we counting by? 250? So that middle is 500. And plot that point. And hour 1, we doubled to 1,000. So at hour 1, we're now at 1,000. Hour 2, we've doubled again for 4, so 2,000. Hour 2, we're at 2,000. Hour 3, we're sitting at 4,000. 3, we're at 4,000. And then hour 4, we're at 8,000. And they just wanted you to go up to hour 4. I think I may, 8,000 is all the way up here. All right, I think I got those right. So this graph is definitely not linear. This is growing by a multiplier. So this is growing pretty rapidly after the first couple of hours. It's going to start taking off. I'm going to curve up there. Kind of color those in a little bit. So let's do the same thing over on graph B. So let's make a table of values. So we've got T and, or in this case, T and P. So T and P. So at hour 0, we started with 100. This is going to be a rough estimate because I know that first line has to be 250. So at hour 0, we're roughly at 100 right there. At hour 1, we are growing by 3, so we're tripling. So we're going to multiply it by 3. So from here to here times by 3, you're going to get 300. So if this one is 250, 300 is just above it. In hour 2, we're going to triple that amount, so that's going to be 900. There's 1,000. I'm sure 900 is just going to be slightly lower than that. And then hour 3, we're going to do 9 times 3 is 27. So 2,700 in hour 3. So here's the 2,000. Here's the 2,500. 2,750 is right there. So we're kind of like just underneath it. And then hour 4, we're going to take 27 times it by 3. Is that 81? Double check it. 27 times 3 is 81 with the 2 zeros. 8,100. So look at that. In hour 4, this one is just slightly more than the bacteria one. Okay, all the way up to 8,000. 8,100 roughly here. And let's curve this guy. Okay. Kind of want to highlight these points a little bit. Tables are very helpful. So they are definitely, if you compare these two graphs, the same curve. They have the same shape to them, except for this parasite one is kind of curving a little bit slower at the beginning. starting lower, clearly, right? And it's curving slower, but it starts to take off a little bit faster as we get to the higher hours compared to this rate of change over here on the first one. Number 2 is asking on the graph of n. So this is the graph of n. This is the graph of p. Where can you see each number that appears in the equation? So let's rewrite the equation. N 500 times 2 to the t. So where can you find each number? So where's the 500? Well, I hope most of you can see that the 500 is right there at that initial amount. So this is your initial amount, and another word for initial amount is your y-intercept. No different from graphing lines. The initial amount was at the y-intercept. The 2. How can we see the 2 in the graph? Well, I don't see the 2 in the graph, other than the fact that the 2 was used to help me get each output number. And that is what we call how we grow. How is our output numbers growing? So from year to year, we times it by 2. From 1,000 to 2,000, we times it by 2. We times by 2. You know what I mean? So the 2 is not necessarily visible in the graph, but it's clearly visible in the table, and it's used to find the output values. So it's how our graph is growing. And we're not adding, we're multiplying. So we call the 2 the growth factor. And I'll show you, right? This 1,000 came from 500 times 2. This 2,000 came from 1,000 times 2. This 4,000 came from 2,000 times 2. And this 8,000 came from 4,000 times 2. So it's your growth factor. And we can apply the same concept to answer number 3. How does the 100 and the 3 appear in your graph? So if I rewrite the equation down here, P is equal to 100 times 3 to the t. The 100 is our initial amount, which is also called the y-intercept. Where are we starting? The 100 is your initial amount. And then your 3 is your growth. Because we're multiplying, we call this growth factor. And we ended up getting this point right here by taking 100 times 3. We got this point by taking 300 times 3. We got this point by taking 900 times 3. And we got this last point by taking 2,700 times 3. So make sure you understand by the end of this lesson what a growth factor is and where it's in the equation, and where you can find the initial amount, or other words, the y-intercept.